Hello and welcome to lesson 4D on factoring trinomials. In this lesson, we're going to review something that you learned in Algebra 1, which is the AC method of how to factor a trinomial. If you weren't at Parrish for Algebra 1, this is the method that we taught our students. You may have learned a different method in another school, but if you like your method, stick with it, do your thing. If you don't like your method, this is a really good way to do it. And the key to factoring a trinomial is a four-step process. First, you're going to put your trinomial in the form of ax squared plus bx plus c and find the product of a and c. You're then going to systematically list out all possible combination pairs of a times c until you find one that adds up to b. Then you're going to split the middle term of your trinomial, and using that pair of factors as coefficients, and then your last step is to factor by grouping. So let's do an example together. Number one, I've got 3x squared plus 14x plus 8. We're already in descending order, ax squared plus bx plus c. So now I'm going to list combinations of a times c that add up to b. That's my goal. Well, a times c is 24. We're going to multiply to 24. We want to end up adding up to 14. So let's list all the ways to multiply to 24. 1 times 24, 2 times 12, 3 times 8, 4 times 6, 5 doesn't go in, and I'm into 6, which is already here. So those are all my ways to multiply to 12. And I want to add to positive 14. Well, looking at this, 2 times 12 adds to positive 14. I'm going to use that to split this middle term. So I get 3x squared plus 2x plus 12x plus 8. So these two numbers were then used right here to split the middle term. And what I'm going to do now is I'm going to group my first two terms and my last two terms, and I'm going to take out a GCF on each of these. My first two terms, the only GCF I have here is an x. So I'm left with 3x plus 2. My last two terms, on the other hand, I can take out of 4. And again, I get 3x plus 2. I'm really happy now because these match, which means now I can factor by grouping. So I'm going to take my 3x plus 2 out front, and what's left behind is x plus 4. And now we're fully factored. So that is how we factor using the AC method. All right, let's take a look at number 2 now. And I like number 2 because some weird things happen with the variables. So number 2, we're already in ascending order. 2x squared plus bx minus plus c, so we're in the right order. And my AC, a times c adding to b, a times c is 2 times negative 15, which is negative 30, and b is negative 1. So I'm going to list all the combinations to get to 30. And there they are, all the ways to multiply to 30. And I want to add to negative 1. Well, when I look at these, none of these with both of them positive add to negative 1, but here, if I make the 6 here negative, 5 plus negative 6 would add to negative 1 and multiply to negative 30. So all of my signs will work. So that's what I'm going to use to split the middle term. So I have 2x squared y squared. Then this middle term splits to plus 5xy minus 6xy minus 15. It doesn't matter what order you put these the split term in. I could do the 6 first or the 5 first. It doesn't matter. All that matters is that your sign is what it needs to be. So now I'm going to group the first two. I'm going to group the last two. Here, my GCF would be x times y. And I'm left with 2xy plus 5. My last two terms, my GCF is a minus 3. And I'm again left with 2xy plus 5. So if you notice now, these match, which is what I want. They're going to come to the front. 2xy plus 5 times xy minus 3. And we're fully factored. I want you guys now to take a look at number 3 on your own. Go ahead and do number 3 on your own. So working through this, I got 4x minus y and 3x plus 5. Please make sure you have the correct answer in your notes. The order of these terms factored doesn't matter. I could have the 3x plus 5 first and the 4x minus y second, but the point is that those are my two things in parentheses that I need. All right, guys, go ahead and take a look at number 4 now and try number 4 on your own. All right, guys, go ahead and check your work on number 4 as well. Okay, let's take a look at number 5 together, though. So number 5, I have x squared minus 13x minus 36, and I am going to still AC method this guy. So we're looking for a times c is negative 36 and b is negative 13. I'm going to write out all the factors of 36. 1 and 36, 2 and 18, 3 and 12, 4 and 9, 5 doesn't go in, and then 6 and 6. So now we're done. I need these to multiply to negative 36 and add to negative 13. Well, 4 and 9 would add to positive 13. So if I made them both negative, they'd add to negative 13, but they wouldn't be multiplying to negative 36. So actually, none of these are going to work. There's no combination of these two numbers where I could multiply to negative 36 and add to negative 13. So we actually going to say that number 5 is prime because there's no way to factor it. Let's take a look at number 6 now. Number 6, my a times c is 15 and my b is negative 8. Well, factors of 15 are 1 and 15, and then 3 and 5. Well, if they're both negative, the 3 and the 5 both negative, they would add to negative 8 and multiply to positive 15. So that does work. I'm going to split this middle term. I get x squared minus 3x minus 5x plus 15. Group the first two, group the last two. I can take an x out of the first one to get x minus 3. Take a minus 5 out of the second one to get x minus 3 again. These match. So I get x minus 3 times x minus 5. Now, here's the deal, guys. If you notice, these numbers are the same as the numbers we found here. And that's because when your a value equals 1, you can go straight to factored form. Go straight to factored form. It's an easier problem then because you don't have an a value throwing things off. So let's do another example together where I don't have to split the middle term and do that step. I'm still going to look for a times c and adding to b, where my a times c is negative 20 and my b is 8. So that'd be 1 and 20, 2 and 10, 3 doesn't go in, 4 and 5. So looking at this, if I do 2 and 10, where the 2 is negative, I can jump straight to factored form. This becomes x minus 2 times x plus 10. All right, I want y'all now to do number 8 on your own. All right, guys, check your answer. And now go ahead and do number 9 on your own. Number 9 ends up being prime because, again, I had to think about a times c and add to b. Well, there's no combination of a times c that can add to 1 because 30 is positive, the 1 is positive. 5 and 6, if one of those could be negative, could get us to 1, but we can't have a negative because I have to multiply to a positive number. So this guy is just strictly prime. All right, let's take a minute now and do number 10 on your own. Well, I like number 10 because the a value is 1, so it's a much faster problem. When I look at my values, numbers that multiply to 25 and add to negative 10, well, the way to multiply to 25 is 1 and 25, or 5 and 5. If I make both the 5s negative, then they would add to negative 10. So I get x minus 5 times x minus 5. We could actually rewrite this as x minus 5 squared. Put a pin in that because we're going to come back to it here in a minute. All right, let's take a look now at these. This whole section is to show you that your signs really do matter. Here you can see all 4 of these questions have essentially the same setup. X squared, a 10x, and a 24. But each of them has a different combination of positives and negatives. And what I want to show you with this is that depending on where the positives and negatives fall really changes your answer. So let's look at number 11 together. I'm multiplying to 24 and I'm adding to 10, both of them positive. So we've got 1 and 24, 2 and 12, 3 and 8, and 4 and 6. So in order for these to multiply to 24 and add to positive 10, I like plain old 4, 6. And so this becomes x plus 4 times x plus 6. Again, my a value is 1, so I can go straight to the answer. Number 12 is a little bit different. Here's my table of values from before, except now the 24 is going to be negative. So I need to multiply to negative 24 and add to positive 10, meaning that one of these values must be negative in order to multiply to a negative. If I make the two negative, negative 2 and 12 are my guys, because negative 2 plus 12 adds to positive 10. So my factored form ends up being x minus 2 times x plus 12. Well, something similar is going to happen on 13. Again, here's my table of values, but now I'm going to put a negative with that negative 10. And so I need both of my coefficients to be negative and add to negative 10 to multiply to a positive number. So if I make that negative 4 and negative 6, these two would multiply to positive 24 and add to negative 10. So my factored form ends up being x minus 4 times x minus 6. And last but not least, if we look at number 14, again, same table of values as before, but now I want both of these to be negative. That means I need one value to be negative, one value to be positive in order to multiply to a negative, and the larger value needs to be negative in order to add to a negative. So I make that to a negative 12 to get where I want to go this time. So it would be x plus 2 times x minus 12. So guys, you got to watch your signs really carefully. All right, I told you we'd be coming back to that x squared minus 10x plus 25. Well, here it is. We have, this makes a perfect square trinomial because it factored into some quantity squared. And guys, that should be an x right there. So if you can recognize this pattern, this perfect square trinomial pattern, you can save yourself a lot of time factoring. So for example, a plus b whole quantity squared, when I FOIL it out, gets me a squared plus 2ab plus b squared. Similarly, a minus b whole quantity squared factors into a squared minus 2ab plus b squared. So I want to look at some problems and see if we can determine when this pattern exists and show you just how quickly you can jump into your factored form without having to go through the AC method every single time. Will AC method work? Yes, it will. You can do that. But if you can spot this pattern, you can save yourself some time. So when I look at number 22, I'm trying to decide, is this a perfect square trinomial? And right off the bat, I see that these two numbers are not perfect squares. And because of that, this is not a perfect square trinomial, because if you look at our pattern here, the first and last term have to be perfect squares, and that includes the coefficients. So let's look at number 23 now. Number 23, my first and last terms are perfect squares, where if I took the square root, my a value would be 3, and my b value would be 5, okay? The middle term is always 2ab. Right? So I want to see now, is this the same as 2ab? Well, is it 2 times 3 times 5? Yes, it's 30. Check. So this is in a perfect square trinomial form. And so I'm going to factor this guy. He's going to be a squared, or a, and then something to do with b, which is just 5. And my question is this supposed to be a plus or a minus? Well, looking here, I've got a minus sign right there. Well, when I've got a minus sign right there, it's going to be a subtraction problem. So it's 3x minus 5 squared. Let's look at the next one. Real quick, I wanted to determine if I've got an a, or if my a and b are perfect squares, which they are. So a here would be 10a, and my b would be 7. And my question now, is this the equivalent of 2ab? Well, that would be 2 times 10a times 7, which when I multiply that out is 140a. So yes, it works. So this is a perfect square trinomial, and I'm now going to go and put it in its correct form. These are both plus signs, so it's going to be of this form, the a plus b whole quantity squared. Well, my a was 10a, and my b was 7 whole quantity squared. Save yourself tons of time. Let's look at number 25 now. Number 25, these are both perfect squares. However, if you look, your b value is always positive in both of these, always positive. This is a negative. So this is not in perfect square trinomial form, right? Not a perfect square trinomial. And I can just stop right there. I could probably try to see if I could AC factor it, but I know I can't use a shortcut. Perfect square trinomial. Whoop, spell it correctly. No-meal. There we go. All right, let's look at the last one. So when I look at this, my first term and my last term are perfect squares, so the last term's positive. My a value would be 2a. My b value would be 3b. And my question is this the same as 2 times ab? Well, that'd be 2 times 2a times 3b, which is in fact 12ab. So yes, that works, which means this factors into 2a, 3b, whole quantity squared. This is a minus sign, so there's a minus sign there. And we're done. All right, guys, we're at the end of the notes. Please take a look at the practice assignment, and we'll see you in class. Thank you.